Earlier this morning, I received an email from one of our power users who asked a really good question. He wants to be able to display the time since a data point has changed, wants to be able to display that in, say, a label in WebView, and he wants to know how to go about using script to capture that information. So I thought rather than responding via email that I would produce this video blog just to show you exactly how we can use the IVqt interface to display something like the time since a data point has changed. IVqt is an interface exposed on a data point. VQT stands for value, quality, and time, which are primarily the three main properties that we want to work with when we're dealing with tags or with data points. So let me just jump over to WebView and get started by adding a couple different components here. So I'm going to add a gauge and I'll add a slider. And I guess I can also add a checkbox, a simple checkbox. And I'm going to bind this information to DataPid. So let me just start up DataPid. And I'll bind my gauge to PV. And you can see it's moving already. And I'll bind my slider to my set point, and for the sake of illustration I will bind my checkbox to auto mode. And as some of you have seen before, we know that we can bind control values not only to the value of a data point, but also we can bind them to labels. So for example, rather than typing in text for my checkbox, I can actually bind that to a data point as well. So I'm going to choose again to bind it to auto mode, but I do not want to bind it to the value associated with that point, but rather I want to bind it either to the the fully qualified point name, or maybe to some other variation of it that includes subdomain or just the point name itself. And of course I can do that here. I can do it on the gauge. I can do it wherever I feel is necessary. So let me just do that as well. That is on the dial text. That's it. Dial text property of the gauge. And this one was bound to PV, and again I'm going to display that with some variation. Okay. At any rate, I have at this point some controls that are bound to the various properties of this PID controller. And if I turn off auto mode, you'll see that my set point is now going to stabilize around whatever that is, 49 I guess right now. And obviously if I change my set point, then my process variable is changing. But I'll just turn auto mode back on again, because really what I want to be able to do is deal with the timestamp data associated with these controls. So let me just, I guess, start by illustrating how I can at least access the timestamp of a data point that has been changed. So I'm going to bind this label to a script expression, and I'm just going to use my get function to access the data point. I'll just access my set point because that's really the one that's, whoops, sorry about that. That's really the one that's changing fairly quick, very frequently, every 5 seconds or so. And what I really want to do though is output that. I guess let me just, for the sake of illustration, capture that in a variable. What I really want to do is just output the timestamp of the last time that was changed. And so you can see here that every 5 seconds, every time my set point changes, the timestamp, which is currently expressed as an OA date, or if you will, just a big a double, that's updating. Well, I can also display that information as a local time, and so I can see that it's formatted appropriately, and again every 5 seconds or so that is changing. Well, that information is using the IVqt interface. And so let's just jump over to our help screen, and I'm going to navigate down to Data Hub Web View Scripting. I'm sure some of you, well, many of you have probably been here before. And when it comes to working with data points, you'll notice that the name, value, timestamp, and quality are primarily the properties that we want to work with. And I can see that my get function is going to allow me to access a point by name. And again, it supports a couple of different interfaces. One, the data table for things like use in the filtered data table control, or the IVqt interface. And I can see that my IVqt interface again supports those properties, and I've illustrated how to use timestamp and timestamp as local time to access that. Well, in our example, or to respond to the question from our user, he wants to know how to display the difference in time from now, or if you will, how long it's been since a particular point has been last updated. So a little bit of a trick to this. Clearly we want to be able to do a little bit of subtraction, but there's a little bit more than that going on. And the first thing I'm going to do is I'm going to put a label out there, and I want my label, again, I'm going to bind it to a script expression in this case. I want my label to actually say something like duration since my point name, and so I'll display that as pt dot point name last changed. And what I want to be able to do is to define or grab that variable, again var pt, by accessing a particular data point. However, in this case, rather than actually typing in something like, data PID1, etc., what I really want to be able to do is access the point from the parameter that was used for this slider. So I'm actually going to add another variable, a property, and this guy is going to access the page object, which you may recall is an intrinsic object for all script, and I want to grab a parameter. And the parameter that I want to grab is going to come from this control. And so you can see that this slider has a name of slider1, and what I really want to do is grab this property or this parameter. And I'm going to start by copying that as a reference and then coming back to my code again. And so in here I'm going to paste that reference. So what I really want to do is set a property or a parameter to point to slider1 at value. And then that really is referring to obviously the value parameter, but what I really want to do is grab the point binding for that. And so I'm going to, on the next line, come back down here and say, rather than using just that parameter, what I want to do is get the binding expression from that parameter. And the binding expression that I want to use is actually the one associated with the point binding. We of course can have simple bindings, point bindings, and script bindings. So this should give me access to the slider1 value parameter. This should now say, what's your point binding expression, and see if you can find a point with that name, and it should work, and then display in our label what the name of that point is. And you can see that sure enough, it has worked correctly. So there is my label, which is really nothing more than a text concatenation of the phrase duration since plus the point name, which is data pid1.sp, and last change. And this approach of accessing a parameter and then grabbing the point from it is actually pretty valuable. So I'm going to come in here, I'm going to copy that because we're going to use that again in a second, and I'm going to add another label to my form, and this is going to contain the difference, if you will, between now and when my point has last changed. And so I'll start off by pasting those two expressions back in there, which gives me access to PT, and I should know now that PT dot timestamp as local time, if I were to just hit apply on that, you'll see it's displaying in here the local time of that last change. Okay, now you may notice we have a couple problems. Specifically, as the auto mode is changing my set point, you can see that this is actually changing here. This one is not. I'm going to come back and we're going to deal with that a little bit later. For now, I want to change my output. Rather than displaying the local time, I'm actually going to display the current time minus PT timestamp as local time. So that should give me the difference between when that point was last changed and the date right now. And so this is in essence displaying it in terms of seconds and partial seconds. Now, once again, you'll notice that this is not changing right now. And the reason is that in order for it to change, this script expression needs to be reevaluated. And in order for a script expression to be reevaluated, WebView needs to know that it needs to be re-triggered or re-updated when something in particular occurs. Sorry about that, folks. I just got interrupted there, and I'm back now, so there's a bit of a glitch in the video. I apologize, but let me continue here. So what we were in the process of doing is talking about how we need this script expression to be automatically regenerated. So I'm going to come up and add a reference to the slider property. So you'll notice that when I do that, now my time is going to be automatically updated whenever the value of the timer changes, which is right now every 5 seconds or so. And that's because this getP function is automatically leveraging something, let me just jump over here, called automatic script evaluation. And you can see that's discussed inside the help documentation under advanced features. And automatic script evaluation is something that is hooked, if you will, to the val get and getP functions. So whenever you have a literal specified as the property name, the point name, or the point name for getP, get, or val respectively, then that script expression will automatically get reevaluated whenever the value of that expression changes. So in this case, whenever the value of slider 1 changes, that's a trigger to say go ahead and reevaluate this script expression. Well, you'll notice that right now the granularity is not exactly what I want. I probably want this updating a bit more frequently. So one of the ways that I can do that is just to use the timer control. I'll put that on my page, and I'll notice that right now my timer is set to increment every 1 second and just to count up. And I'm going to actually enable that and turn it on so that it's running right now in design mode. Timers by default only run in run mode, but I'm going to run it in design mode anyway. And I'm going to notice that this property here is the one that I actually want to hook or tie into. So this timer was called timer 3. I had just played with the timers before. I'll just rename that to timer 1 for the sake of illustration. And I want to come back into my script expression. And so in addition to saying I want my script expression to automatically update whenever slider 1 at value changes, I'm also going to tell it to update whenever, and I actually copied that expression. So let's paste that reference, and then I'll update that to timer 1 again. I also want to update it whenever timer 1 at current value changes. And you'll recall that the granularity of the timer right now is 1 second. So when I hit apply, I will see that right now my counter, if you will, is updating in 2 different situations: every second, because that's how often the timer is firing, as well as whenever the set point changes. Well, that allows me to now go back and change the increment or the granularity of my timer, and I'll change it so that instead of running every second, it's going to actually run 10 times a second. And you'll see now it's reflecting anywhere from, say, 0 to 5 seconds how long it's been since that set point value has changed. And so by illustration, if I go into run mode and I turn off my auto set point, I'll see that this will continue to run to show the elapsed time since that set point has changed. And if I drag my slider, I can see that, yeah, sure enough, that has started over. So in this video blog, we have illustrated how we can access the timestamp and timestamp as local functions, which are made available, or properties actually, which are made available through the IVqt interface, which is available for all data points, and how we can use automatic evaluation to automatically re-evaluate a script function when some event occurs.